and extremely low fees designed to support initially IoT applications. During the last year, we are while still focusing on improving on the layer 1 blockchain, which, by the way, I did not say it's a fully Ethereum compatible, even if it's been built from scratch. We have been now building for 1 year a new protocol, a layer 2 computational protocol that we call WebStream. WebStream is a protocol that's based on a WebAssembly virtual machine for the computational part. It's a modular architecture. It has integrated smart contract interaction, integrated SQL data storage, in the future also decentralized data storage, and HTTPS and MQTT connectivity for smart devices in the real world, and a nice UI admin interface. So today we are anyway not going to focus on this protocol, but if you are interested in dive deeper in WebStream, we have a nice real-world event dedicated to it on March 3rd. Here is the address and the QR code. This is a limited entrance, and you will find a lot of demos, presentations from great projects, and everything is about connecting Web3 with real world, with the physical world. Scan the QR code if you want to register and attend the event. This is, for example, one demo that uses WebStream that you will see during the event, where we demoed how you can build a power meter that can send energy consumption data to the WebStream layer 2 protocol that will then compute proofs for low energy power that will then trigger rewards on the layer 1 blockchain. So this is just a slide that shows how WebStream is, where the WebStream protocol is located. It's a layer 2 protocol, and it's basically facilitating connecting data from the physical world and then computing proofs that then can be ingested inside smart contracts. As I said, we're not going to focus on this protocol that much, but we are going to focus on a trusted location API, which is an application or a product that we built on top of the layer 2 protocol, WebStream, to show how you can actually connect smart devices, GPS location for your users, if you are a dApp developer, how to connect this location data with your smart contract applications while preserving the privacy of the user, and at the same time trusting that the location is tamper-proof. So opening the door to many new type of applications, ranging from, I don't know, scavenger hunts, games, or applications, itinerary type of applications, earning rewards for in-person attendance, right? Or GameFi, or just location verifications to limit or give access to special features into your dApps, or to gain access to specific levels of your games, for example, based on the location of the user or based on the itinerary of your user. So as I said, you should be able to easily follow along today, because we also have this workshop on our developer portal. So you should be able to copy paste the code like we do very easily. Otherwise, you can do the same later. So what you're going to need anyway is, of course, your laptop. You need Git installed in your computer. You need NPM. Hopefully, you already have these tools installed. MetaMask, of course. You will need the IoPay mobile, which is the IoTeX official mobile wallet that is also cross-blockchain. So you can use it on any popular blockchain, not only IoTeX. It's not like mandatory for this, but if you download it, you will also be able to test the application. And then possibly you need an account on the IoTeX developers portal to claim the test tokens that you need to run the workshop. I will show you. So first, let's maybe see a live demo of what we are going to build today. Giuseppe, you want to try?
Yeah, why not?
Right.
I'm so glad I know what he's talking about, because I'm having a hard time hearing. But if you guys at any moment something is not clear, you want to ask questions, just feel free to, and we'll be happy to answer them. All right, let's see what happens. Yeah. Oh, thank you. Cool. Actually, I'm gonna just go back. Is VS Code open? Is VS Code open? Is the VS Code open already? Okay, cool. Ah, you're right. The keyboard is different. Simone is using the Italian keyboard.
Zoom in, please. Zoom in.
All right, you're right. You're right. It's hard. All right, so I'm gonna do it through VS Code.
Giuseppe.
Yes.
Zoom.
Simone, can you zoom in a little bit? Ah, grazie. Ah, nice. Cool. All right, so basically, we have this here. This is going to be the project that we're going to look at later. We have a front end and a web 3. All I'm going to do now is go and run the front end on my local host. And then I'm going to run it. Simone, can you come here? Lo apri, per favore? Yeah, I know. All right, cool. So what we're going to do now is, so this is basically what you will get at the beginning of the application. And we haven't created any airdrops. In general, what we're going to do now is basically create an airdrop based on a location. And we picked, obviously, the Biddle Hub as our location for the duration of, let's say, Biddle Week. And we're going to allow only people that signed in from this location to be able to claim their NFTs. And so that's basically what we're going to do now. So what I'm going to do is start creating an NFT, and I pre-checked the coordinates for Biddle Hub, and so that's what I'm going to input. And so this is going to be... And then longitude is going to be... Cool. So now, for example, as an airdrop creator, you can decide, okay, cool, I want people in the Biddle Hub to be able to claim this NFT, and let's say that we're going to put maybe a max distance of, let's say, 100 meters, right? So only people that were following this workshop. We're going to pick up a date. And let's say that we go from yesterday, which was start of Biddle Week, until, let's say, next week before everything starts. So, and we're gonna create maybe 5 tokens for the lucky 5 people that will be able to claim this. Okay. So next, I'm gonna submit, and this is going to then call the smart contract and create the airdrop. And then we're gonna wait a little bit, and then we're gonna refresh the page and have our airdrop. Cool.
This is how fast the IoTeX blockchain is, by the way.
Yeah, that's a good point. I mean, we are on chain, right? So we just created this, and it only took a few seconds. So that's a pretty cool perk. So, for example, what we have now, it's this airdrop with these coordinates, and obviously, mind you, this is just like a little, little toy, a little POC to show what we want to do here, right? So you're free to check out the code, improve it as much as you want, but basically, the next step here would be to claim this NFT. So before I do that, I need to check in my location using IoPay wallet like I did before. So since this is Simone's computer, I think if you want to check in with IoPay. Did you already put the location? Ah, okay, got it. Cool. Okay. So what I basically did, I'm gonna do it through my phone because I think it's better. But basically what I did, I signed in the location with my phone, and that's how you guys can do it. And then let's see. Qual è il mio account? Non è questo. Okay, so I'm gonna connect this account. Non è questo? Okay, cool. Nice. So I connected my account. I had previously signed in with my IoPay wallet. And just mind you, we had prepared this to be a little bit different. So I was going to do it from my computer. So that's why I'm having a little bit of difficulties doing this. But, that's the beauty of going live, right? So hopefully we'll make it work. So I'm signed in with this account. This is the account that I imported through my IoPay, through my phone. And now I'm going to try to get the proof for this NFT here because I signed in from this location, okay? So the next thing I'm going to do is ask for the API to say, okay, was this person here? Can you send me the proof? And if so, then allow me to claim the NFT contract. Con quello. In case I forgot, yeah. So now it's telling me to claim my NFT, right? So the API basically responded with a positive proof saying, yes, this person was here. I logged in, like I said, through my phone. Now I'm able to claim the NFT. So I'll go ahead and now call the smart contract. And I think it'll take maybe a few more seconds before I actually end up claiming the NFT. So once the claim has been successful, I could basically go to my airdrops page and see that I've actually indeed claimed this airdrop. And then obviously there'll be one less airdrop for people to claim. And obviously this can be anything. So it can be any sort of valuable perk that maybe a creator wants to create, maybe a musician, or maybe like Simone was saying, maybe gamers or NFTs or any sort of metaverse that you want to attach to a location. And again, location is just one example, and that's what we picked for today because we thought it was pretty cool. So this is the final working version of the app, which is basically what we're going to build today. In the repo that we're going to share, there are going to be two branches. There is a main branch, which is this, and there is also the starting template, which is basically what we're going to start with, and that's what Simone is basically going to start doing next. So I'll take my mic, I'll shut up, and I'll give it back to Simone.
Thank you. Actually, yeah, maybe I can still show you what Giuseppe did on his phone. Let me see. So this is the IoPay mobile wallet. I'm running it on the desktop. That's what you will see on your smartphone. So this is what your users will use to communicate their location to the location API. And yeah, actually, yeah. Can I show your private key to the people?
One more time?
Can I show your private key to the people?
Yeah, you guys can all take my private key. Don't worry about it.
Okay, so let me go to the settings, wallet, manage wallets, import wallet, and I'm importing your private key for everybody to steal your test tokens right now.
That was the surprise that we were hinting at earlier. The surprise is take everything I have in my wallet and just go with it.
That's anyway.
Simone, I think the screen...
I know. That's a private key.
No, it's okay.
And you never know.
Okay, fine.
Full of hackers here. Okay. Should have not disconnected.
Okay, here we go.
Here we go.
Cool.
Okay. So I've imported the wallet.
Yeah, that's mine.
That's yours, okay. And so basically inside the settings of the wallet, by the way, in IOP you can switch to any other blockchain. You can use it on any other popular blockchain that you want, not only IoTeX. So if I go to the settings, there is a web stream, and there is a geolocation plugin here that's off. So that's where you actually register your device with the trusted location API. Yeah, I love it. That's what your users will do to somehow join your dApp with their trusted location. Okay, enable. Okay. Okay, so basically here you can enable either only once and then disable it if you want just to send your trusted location once, or you just can leave it enabled and then set up like the interval, how often you want the location to be sent. Anyway, this location is not going to be shared, not even with dApps, right? Even when you interact with the dApp to request the proof, it's the responsibility of the dApp to provide a location to the API, plus it has to be signed by the actual user you are querying the proof for, and then the API will only return you the proof saying yes or no. The location that you provide, the user was actually in that location that you provided. So the actual user location is never going to be leaked. Okay, now that said, are there any
let's get to the code, right?
Yeah.
Let's do it.
We're going very fast, actually. If there are any questions?
Any questions out there? Not at the moment. Okay, let's keep going.
Okay, great. So one thing I want to focus on is our developers portal. That's because that's the easiest self-service place if you want to start building on IoTeX, so you don't have to ask anything to anybody. Just go to the developers.iotex.io, right? And you just log in with your GitHub account here, and you can go to your dashboard. You can connect your wallet, and then you can claim some test tokens right away, every day. So you can like start building immediately. And yeah, there should be like 100 new test tokens here at some point. So I invite you to explore the developer portal. Here you can also find the IoTeX Academy, and we are also releasing a community hub where you can contribute your own projects that you have built, and also you can get tips from other developer users for what you have published on the developer portal, everything Web3 based. So once you have claimed some test tokens on the developer portal, you have your MetaMask account ready, then you are ready to go with the tutorial, which, by the way, you can find inside the Academy, or it's also on the homepage here. Or you just go to the Trusted Location API and click on the full demo tutorial. And this is the workshop we are going to follow along, right? But it's going to be probably 45 minutes, so be patient, ask questions if you have any questions. So here in this image, you see what we have been talking about until now, right? It's actually the simple architecture of a dApp that uses the Trusted Location API. On one side, there are your users that are IOP users. They have checked in with IOP with the Trusted Location API enabled. And so their device will send, based on their settings, will send some their trusted location to the API. Then we have our dApp frontend, and then we have our dApp smart contract, right? The front end allows the device owner to claim airdrops, and it allows anybody to create an airdrop by providing the location, the radius of the area, and the time range, and the number of tokens that they want to provide to people. The smart contract, instead, is basically, the smart contract side is basically just the NFT smart contract, a standard NFT contract that we use as the airdrop to mint the airdrops. And there is the actual logic for the claim, for airdrop creation and airdrop claiming. The airdrop creation is straightforward. The claiming part is basically it's going to need the proof coming from the API. It will verify that the proof is actually valid, and then it will trigger the logic. In our case, the logic based on the location is just verifying that the actual location still has NFT available, that user has not already claimed that NFT, and then just trigger the minting. So I'm just following the workshop here, and you can do the same. So I start from cloning. Let me put the microphone here, maybe. Okay. So I will start by cloning the repository, and specifically I'm cloning the starting template branch. So you also can just check out to this branch, and that's basically the full application that Giuseppe has shown, but with some missing components. Those are the ones that we're going to build today. So okay, I'm going to clone the branch, the starting template branch of the repository. Enter. And I'm now showing you the smart contract part first, which is pretty easy. So just enter. There are two folders inside the workshop. One is the front end, which is basically the Next.js UI you have seen before. The most important component is missing, and Giuseppe will show you how to build it later. And the Web3 folder just contains an Hardot project for deploying the smart contract. So I'm opening VS Code here. And we're focusing on the smart contract for this application. So we have the location airdrop smart contract. That's the actual logic for creating an airdrop and claiming an airdrop. Then there is the location NFT, which is just a standard NFT contract that we are going to use to mint the NFTs. And here is the verifier interface. This is the interface of what's called a verifier contract that is officially deployed by IoTeX on the IoTeX mainnet and testnet. And the role of this contract is to verify the trusted location proof, so making sure that the proof is valid. So we import the interface to verify the proof before we actually mint the NFT. So I'm going to start from where these contracts are already, these are standard. This is a standard contract. The interface is inside the documentation, so we are going to focus on our own logic here. That will be your dApp. So let me maybe hide. Okay, a little bit smaller.
Yeah, that's pretty good.
It's pretty good, okay.
Yeah.
Okay, so let's get back to the tutorial page. Oh, I should do an npm install. Let's do it first inside the Web3 install to install just the Hardot dependencies to deploy the contract.
Let's do also the front end, so then...
I'll do the front end, yeah. I will just start at the front end.
And then we can just spin the server too. So then we start adding components to it little by little.
Yeah.
And for the front end, we're basically just, like Simone was saying, we use Next.js. And then we use WAGMI to interact with the contracts. And then we also gonna interact with the trusted location through a little NPM package that we made for it. And I'm gonna describe what the package does, and then I'm gonna show the code as well in the documentation so that you're able to also do that on your own if you decide to build on top of this.
Yeah, I'm just deleting some services that I have. Okay. So I'm going to run the front end, which is basically empty. Run dev. Okay, so here is our front end, and it's basically missing the most important component, which is the card that allows to manage the claim. So Giuseppe will go through that part later. We are actually going to work on the smart contract side. So getting back to the workshop. So the first thing, we import our NFT token contract because we have to mint this token. And we import the verifier interface because we will use the verifier, the trusted location verifier contract, to verify the proof of location. Okay. Next, let me update the page. Okay. Next, I'll start adding some global scope for our contract. Right? I will also add the constructor here. So what we have here, we have this event. This event is emitted every time a user successfully claim an airdrop. We have the actual verifier contract that we'll initialize in the constructor, and we have the NFT contract to mint our NFT. We have some make money part where the admin of the contract is maybe possibly interested in making some money out of this contract. So we set up the address of the contract administrator or whoever will receive the fees for those who create these airdrops. We set up just a base fee. That's the cost for each NFT that an airdrop creator will pay for each NFT that they want to associate to their airdrop. And then we have a cliff. We don't want to get too much money out of these people. So you can set the maximum number of NFT you ask for a fee, and the rest is for free. Then we have the actual structure that holds the information for each airdrop. So basically the latitude, the longitude, the distance of the region, and the start and end time range for the airdrop, and the number of NFT tokens that you want to airdrop to people. And then we also keep track of how many have been minted for each airdrop, right? Here we have some classical structures to manage the list of our airdrops. So we have here just an array of hashes where each hash is the hash of every single airdrop that has been created. We somehow index them by their hash. Then we have the actual mapping where all the created airdrops are listed, are stored. So this mapping goes from the hash of the airdrop as an ID, as a unique ID, to the actual airdrop data. And then we have a mapping to a mapping that basically maps each user, if a specific user address has already minted a specific airdrop or not. We don't want to allow users to double claim the same NFT. And then we have just the token ID. This is just a unique ID for each new NFT that we are going to mint, and this one is just going to increase on every new NFT. And the constructor is straightforward. It's just initializing all the global variables that we are going to use. So when you deploy this contract, you will have to pass the IoTeX official verifier contract, the address of the NFT contract that you want to use, the fees, the fee receiver, and the cliff. And this is for the global scope. Right? I think here is everything more or less what I've said already. So we can go ahead. We can go ahead and add some like utility functions here. So these one are pretty simple. This one will just tell you the total number of airdrops in the system. This will give you the list of all hashes, so all basically IDs of all airdrops that are in the contract. These are used by the front end basically to list the cards. And then this one is used to generate the hash for each airdrop that is created. So very simple. Then we have the two main functions of this contract. One is used to create a new airdrop, right? What Giuseppe used in the demo to create a new airdrop and then input the location of the Beetle hub and the time frame. So this is the function that basically needs the latitude, the longitude, the distance, the starting, the time range, and the number of tokens of your airdrop, right? And this is payable because you have to pay to create an airdrop. And the payment is going to be based on the base fee, the cliff, depending on how many tokens you want to allow people to claim. So creating an airdrop is pretty simple. Just we do some basic validation that latitude and longitude are valid. You may know that Solidity does not take real numbers, so these have to be integers. And so we expect the latitude to be the actual latitude by 10 to the 6th integer. Same for the longitude, distance or meters, time from and time to our Unix timestamps, and same here, Unix timestamps. Yeah. And tokens count, of course, it's number of tokens to me. Great co-pilot, by the way. And so we do some basic validation here. Latitude should be in this range, longitude should be in this range, distance should be positive. And we also validate that the user paid the fee based on our calculation of the fee. At this point, everything is fine. We will just hash this airdrop data and just store this airdrop in our structure, meaning we are going to, we are also checking that we don't already have an airdrop with the exact same location, distance, and time range, because that would be just exactly the same airdrop. So we are going to reject duplicated airdrops. If not, we just add the airdrop to our mapping using the hash as the index. And mint and tokens, of course, starts from 0. And finally, we also push the hash into our array, and this is due to how Solidity works. You have to have your indexes into an array to have a way, a mean to list all the airdrops that you have. And finally, the most important function is the claim function. So this is the function that allows somebody, your users, to actually claim an NFT. So if they have been in the location that you have published, in the time range that you have published, and there are still NFT available, then that user will be able to call this, I lost it, to call this claim function, passing the actual proof of a location, and this proof is provided by the Trusted Location API. And it's, of course, the latitude, the longitude, the distance, the time range, and then the API will also give you the device hash and the signature. This is the signature, the proof from the API that the user was actually that the device was actually in this location at this time. So the claim function will first generate a hash of this like airdrop data to make sure, it will make the hash of the proof data and then verify that this signature is correct, is the actual trusted location API signature of this data. So making sure that this data is not being tampered with. And so we are creating the hash of the data and just calling the verifier contract verify function on the hash and on the signature, on the trusted location API signature. This one will revert if the verify fails and say, okay, this data, this proof is not coming from the trusted location API. Otherwise, if the verifier says okay, then we are going to create the hash of the airdrop data only, right? And make sure that the user, this user, the sender, has not claimed this airdrop already, right? So that the entry in this mapping is false. And if it's not been already claimed, the proof is valid, then finally we have we are going to create our airdrop. Oh, we are still making another check. That basically that airdrop does actually exist because the proof can be valid. I've been in that location at that time, but maybe there is no actual airdrop for that location at that time in our system. So we are requiring that we are fetching an hypothetical airdrop with this hash for this data and making sure that it's there. If it's there, then there should be a max distance positive. And then if it's there, we are also checking that that airdrop has still tokens left for this user to claim. And finally, if everything goes well, then we are like taking note that user has claimed this airdrop. And then we are finally minting that and the NFT to the sender and emitting our event that the sender has successfully claimed the NFT and adding, and increasing the number of tokens that have been minted for this NFT.
I wanted to add something maybe. If we go back to the verifier real quick, imagine it as, so this verifier here is obviously, it's developed by IoTeX, so it's not just any verifier contract. So imagine this sort of like as a double verification, right? So you as a user say, okay, I was here in this location, you query the trusted location API, API will respond yes. But at that point, that's not enough because the contract will check, okay, where did this proof come from? And that's the reason why we use the signature, because we're basically saying, okay, this proof needs to come from a verified server that actually said, okay, you're good to go. And that's what we're doing here with this verify method. Yeah. I just wanted to maybe make that a little bit simpler because sometimes it gets convoluted and it's good to...
Yeah, or if you want to say it in other words, people could just attempt to claim, calling the contract directly without going through the trusted location API, just suggest a location where they have been, just forging the signature, right? And that's why you have to verify the proof. That's the whole point of proof of location. You get the proof and you verify the proof in the contract before you run any logic that depends on the location of the user, and can be your Pokemon Go game or can be any other like application. And actually we are curious to see what you can come up with once you can have trusted the location of your users. So yeah, the smart contract is basically almost done. We only have a few straightforward, like obvious functions to add. And calculate, and it's just to configure the fee receiver, right? Only the owner can change the address that receives the fee. We can change the configuration for the cost, so how much we charge. How much we charge for set base fee? We don't have set base fee. Okay, so we can set up the cliff, and here is how we calculate the fee. So how much we expect the creator to pay when they attempt to create an airdrop, and we just calculate. We just give for free any number tokens over the cliff. Otherwise, they pay for like the base fee by the token count. And this is basically it for the contract. Pretty simple, just basically about receiving the proof, verifying the proof, and running your logic. In our case, the logic is just minting an NFT and checking some concepts that we have in our application, which are airdrops. So I guess we can also...
This point, yeah, we deploy, and then we get rolling.
We can also just deploy it.
We need to create the env file with the private key.
Right. And this is where we show it.
What are you saying?
This is where we show the private key.
Yeah, this is where we show the private key.
But this is not the surprise for you. Connect account details. Anyway, you can get many more test tokens from the developer portal.
I'm totally going to drain this account as soon as we finish.
So we are expected to have an IoTeX private key inside our environmental configuration. Save it and just do npm, right?
That is run.
Yeah, run.
And then is
run.
you can check out, if you check out the package JSON, it would actually be cool, so we can show basically the command.
Yeah, let's take a look. We are using this like we are using this
hard.deploy.
Yeah, these are .deploy. What's here? This one. Yeah, we are using this hard.deploy package, which basically does what hard.dat does. It runs a script for deploying, but in addition, it's also exporting the deployment information, which are the actual smart contract addresses and the ABI of the contracts in a file that then the front end will import directly. So each time we redeploy, we don't have to edit our front end to update the ABI and the address. So it's npm run
deploy testnet.
Deploy testnet. Testnet. That's correct. Let's see.
Cool.
So it's now deploying.
Yeah, that's the NFT. Next, that's the one. And then we can basically jump in the front end. Yeah. I was thinking, since I have a hard time using your laptop, maybe I can talk from here and then you can do the laptop using.
For the front end?
Yeah.
Oh, no way.
Okay, then I'll do it. All right, let's do it. Let's try. Okay, so that's deployed.
It's deployed, right?
Yeah.
Yeah, we have deployed everything. So I guess, for the front end, I guess we have just to follow along with the workshop.
Yeah, cool. And so basically what we do is once you deploy the contracts, they're basically going to be exported in a config file in the front end, and that's what we use to basically tell various, for example, WAGMI hooks that we need, what the contract address is, and the ABI. And that happens automatically, so that then every time we redeploy, we don't have to always update the contract or address and things like that. So I'm gonna now attempt at doing this, see if I can figure out how your laptop works. Oh, thank you.
No worries.
I have tech support on the spot. Cool. So as a matter of fact, we're going to Let me open Keynote. We're going to basically look at the main components of the front end, which are going to allow us to work with our cards, right? So the orchestrator of everything that we've been talking about here is going to be this claim verifier component. Inside the claim verifier component, we're going to have a few buttons, right? And each button obviously is in charge of a different logic. Connect button, it's simple. We're just going to use WAGMI to just connect and get the user address. Then we're going to use this claim button. Claim button kind of works twofold. One, like you saw earlier, you basically ask for the proof from the API. Once that is unlocked, then we will then call the contract. And so the claim verifier component is sort of the component that lets us display and orchestrate this whole behavior. And, oh no, that's a surprise, I spoiled it. All right, so let's get rolling. What we're gonna do is cancel this. We don't need Web3. Even the way we use our mouse is opposite. Like imagine what kind of mountains I'm trying to overcome right now. No, it's okay, it doesn't matter. Cool. So, and that's basically what we have in the tutorial, right? The first thing is we're going to create this use claim drop hook using WAGMI, and that's going to be basically our first contract call. So let's go ahead and import what we need. I forgot to mention that for the UI, we're just going to use, what do you call it? Chakra, if that was ever necessary to mention. Let's see here. Claim drop hook. So we're going to have a hooks directory here. Obviously, the front end, there are many components that come into play. We cannot really focus on anything for time. And so we're just going to start with this, right? So I'm just going to close this. First thing that we're going to do is import a few things. And what we use basically is use contract write and the prepare contract write from WAGMI, the location airdrop, and that's the config file that I was mentioning earlier. Use router just to redirect the user home once they do that. And then we have a verified location type, toast, and ether. It's pretty simple stuff, right? So we move on. What we're going to do is this claim drop, use claim drop hook, it's basically going to need some props, right? And some props is going to be the verified location and one more thing, which is a Boolean, which is this is ready to claim flag. So what's going to happen is, let me just put this in the component and I'll show you. What's going to happen is that, and you will see later on, right? Everything will become more clear as we go. But what you will see happening is that basically once we query the API and we do get the proof, then we will set this is ready to claim to true. And that's going to basically start triggering the use prepare contract write from WAGMI, which will do the prepare call. And then we're actually going to call the contract. So that is ready to claim is very important because that will start triggering the smart contract call, right? So basically that's what we have here. So we're basically passing these two types, the verified location and this is ready to claim Boolean. Next thing, what we're going to do is then take care of the use prepare contract write from WAGMI, and we put it here. And basically, what we're saying here is we are. I mean, if you're not familiar with WAGMI, obviously feel free to go and check it out. But basically, what we need to provide is a little bit of information. Location airdrop, which basically would be the address and the API, which we're getting from what we imported above. And then we have the function claim, which is what we're going to do, the arguments, and then this is the enable flag that I was talking about. So once enabled is set to true and is ready to claim is set to true, then the prepare contract write hook will get triggered. And then this is just a message of value that we're passing to it. So this happens. And then once that is ready to go, then we do call the actual contract write. and return what we have. So, and what we return here is important because basically we're going to use this claim airdrop, which is basically equivalent to the write return that we get from, that's how you do it, okay. That we get from the use contract write. So once this is taken care of, we go ahead and take care of another component. And so the next component that we're going to take care of is the claim button component, and this is pretty simple. This is basically just gonna call the hook that we just created, right? And so we're going to need use claim drop hook, you know, some UI stuff from Chakra, and the verified location type. This button basically needs some props too. It needs to know if the user is ready to claim, and also it needs to know for what location we are making this claim contract call, right? And REST is just refers to some other props based on the UI for this button that we just configured in another folder later. So what we can do is seriously just basically is this scrolling? Okay, cool. Okay, copy this and I'll show you basically the rest in a second. And this is a component that is in the components directory and is the claim button.tsx. So we're going to go there. We get to the components, and it's the claim button.tsx, right? So we can just do this and paste this here. Cool. So what I failed to mention earlier is that, okay, this might seem a little bit clunky, but that's sort of like a way that we found to make this happen. Obviously, feel free to find a better way, you know, and hack this and make it a lot better and make it your own project, right? But basically, what we're going to do is we're going to use this sort of is ready to claim to determine if the proof was there, then attach that value. Otherwise, just basically return 0. And the proof is sent on a. It's basically an array of object, because maybe we didn't mention earlier, but you can query different location at the same time, and then based on whatever proof you get, you will get maybe 1, 2, 3, 4, etc. So that's why we're using the first one, because in this specific application, we're just claiming one NFT at a time. So once that is done, we're basically going to create this handle claim function that all it does is really just call this claim drop, which is what gets returned from calling the use claim drop hook. And then here is the conditions, right? If we're not able to claim, we'll just display that. And if there is any error that we get from WAGMI from calling the contract. Otherwise, what we're going to do is use this handle claim function that we showed earlier, and we're going to use that to claim the NFT. Okay? Pretty simple so far. This is just a component that calls the contract. The next thing that we're going to do is the claim verifier. This is the more complex component that will basically put everything into play. So let's go ahead and do that. I'm getting used to your laptop, by the way. Let's just take a little bit of a learning curve. So claim verifier component, what are we going to do here? Let's import these, and I'll basically tell you what role they have in this component. Okay, so we're going to use WAGMI to sign the message, because basically what we're doing is we need to prepare a message that the user needs to sign with all the right information, right? The location information, which will include the timestamp, the location, the device that we're claiming for, etc. The user have to sign that message. The message is the one that Simone was showing earlier that will be sent to the contract, and basically, you know, that ties into what he was saying earlier. So,
yeah, this is because we do not allow any dApp to just query the proof of location for a user, right? Any query to the proof of location API must be signed by the user that dApp is querying the proof for. So this is where this message gets signed by the user.
Because at the end of the day, I mean, you own your data, right? That's the whole point. And that the app should not have access to your location data to any degree of precision unless you sign that message and you claim, whatever reward we have in the logic of this application. So let's go ahead. There are other things here that we need, but let's unlock them as we go, right? So first thing that we're going to do is start using this claim verifier. This claim verifier basically takes one prop, and that's the airdrop. That's the airdrop that we are claiming for. So let's go ahead and do it. So we're basically passing this airdrop prop, and that's of airdrop type. Now, the other thing, earlier I was mentioning, we have this geolocation package that makes the signing, the validation of the data, and all of this much simpler. And that's basically what we're going to do. So we're going to create a reference of the geolocation object, and then we're going to use this to call different methods in this package to then use the message, take care of the locations, etc. And then we need to know if the user is ready to claim or not for the reasons that were described earlier. So let's go ahead and move on. Next thing we're going to do is basically creating the functions that take care of what I just talked about. So we have the send query function, sign message, handle unlock, and I will tell you in a second what they do. So we go here, and this is what we're going to do. So what we're going to do is this. We have this handle unlock function that basically will use the package to use this scale location with scale latitude, longitude, distance, from and to. And then under the hood, what we do is we use this generate COM message method that will use this location that we just created and then send it together with the address, domain, URI to the message that then the user needs to sign. And then we're using this sign message here, which comes from the use sign message hook, and that's just WAGMI stuff. So once we do sign it, we're going to retrieve the signature, and then we're going to use this signature to for this send query function. Send query is this function here that will call the API, verify location, and at that point, we wait for the response from the API. And if the API responds positively, and we have at least one verified location, then we will set the verified location, and then we will set is ready to claim. As soon as this goes to true, like I said earlier, it will trigger the prepare contract write from WAGMI, which then will allow us to actually call the contract with the contract write. If false, too bad for you. So the next thing that we're going to do is basically render these buttons, right? So if the user is not connected, ask them to connect, and then here. This is the first button that you saw me basically click on earlier to get the proof, and that is here. Once that happens, we call the handle unlock. Like I said earlier, it will trigger the is ready to claim flag. If is ready to claim is true, show me the claim button, which is the second button that I clicked earlier when I did the demo, and then basically it will allow you to claim the NFT. So let's do that. I realize I may be talking fast, and if this is not any of this is not clear, we'll have a little bit of time for questions at the end, so that you guys can ask anything you want, and we can go through it over and make sure it's at least clear. So this is done. I saved this. I have not much more to do. The next thing that we can do is basically run the front end like we did earlier and give it a test drive. And since we're gonna use it with your IoPay wallet, maybe you can do the test drive if you want.
Did we use my IoPay wallet?
No, but we could do it here since your IoPay wallet is here. We can send the location with your wallet.
Yeah, the problem is I don't have test tokens in that wallet, so this will take some time.
Okay, then I can use mine.
Yeah.
So we can just run the front end. Cool. Was it 301 maybe?
Maybe we had it already running. Yeah, we had the previous one already running, but
Cool. And so if I open IoPay wallet now, it's a wallet with my key that you imported, right?
who knows? I can't remember anymore.
All right, let's try.
I think so. Is it yours? I should go to the testnet, right?
Yeah.
So settings, general, and network, IoTeX testnet. Is it yours?
Yeah, it could be 0C837. Yeah, that's the
Yeah.
one. Cool. So we can basically now, like we were saying earlier, we use WebStream to enable geolocation, and we'll send my location once, and then, like we were saying, you can determine the interval of the location. In this case, I just want to do it once.
Let me check the history because I'm not sure location is working from the from the MacBook. So you have to do it from your phone anyway.
Okay, cool.
Anyway, we have seen it running in the demo.
Cool. All right. I mean, I just think it.
Okay. We promise it works. I mean, this is exactly the same repository we ran the demo from. So what else? I would first, let actually disclose
the surprise that I already disclosed. We're hosting a little happy hour for all the developers that joined us for the workshop, and you guys are more than welcome to come and spend some time with us if you want to learn more about what we just did or other types of application that could be built with this technology. We'd be happy to talk to you and just have a good time for a couple of hours.
Yeah, I think it's a few blocks from here. It's a walking distance if you want to come. Free drinks, right?
Yes, it's a full bar, open bar for a couple of hours and food. So feel free to join us. We'd be happy to have you.
Yeah, come over and we are there for the evening.
Yeah, it's Bixby's following. So
yeah, I would ask if you guys have any questions about what we have built. Not sure if it was too entry level or too advanced as a workshop. But or if you have any questions,
or if maybe if they're not necessarily technical questions, but maybe a little bit more about something more high level, whatever you feel like asking. We're here. We have a little bit more time, so why not? Okay, I guess no question for the time being.
Oh, here you go.
Go for it.
Generally, why did you start building it on a separate chain, and why not do this directly on Polygon or something like that?
Why did we actually this trusted location API and the whole layer 2 protocol WebStream that it's built on, it's chain agnostic. We have our own blockchain, that's the IoTeX blockchain, that will have a role into the final decentralization of this layer 2 protocol. Possibly, I'm not going to disclose what the role is, but anyway, some part of the architecture of this layer 2 protocol that allows to connect real-world data with blockchain applications, this is one example, will be somehow connected with our layer 1. But the layer 2 can be used with any other blockchain. It's basically a computational layer that generates proofs and makes it easy to somehow collect data from the real world, verify this data, store the data, and reply with proofs to dApps. And these dApps can live on multiple chains. They can be on Ethereum, they can be on Polygon, they can be on IoTeX. But some requirements will be tied to the IoTeX network. Typically, you can expect probably device identities, right? Decentralized identities of devices, node operator identities, right? This type of architectural level concepts to live on the IoTeX blockchain. But the dApps can live everywhere.
Yes. I'll just jump. It's better.
The main question is basically like if you look up the transaction on the Explorer, does your location show?
And whoa. If you look up the transaction on the Explorer, does your location show? No. It will show the transaction hash and other type of data, but the whole point, and that's what we're asking for, the proof, is that the dApp will never know your location. It's more like a yes or no answer. So it will say, oh, what's your name? Easy. Was Easy here at the Biddle Hub for that specific airdrop? The app trusted location will say yes or no, and that's it. And going back also to the earlier question, this is just one example, right, of data. We just wanted to do location because it's cool, it's easy, and it's a good entry point for people to start understanding how the whole architecture works.
And I think this is the only existing trusted location API for dApps, actually. But for us, it's an example on how to use our layer 2 our protocol. Yeah. Can I just answer a little bit more about Easy?
Yeah, I saw you were itching to answer. But
before I forget.
Go for it.
Actually, all the location data is going into the layer 2 protocol. It's not going on the blockchain. What's going on the blockchain is the proof that the user was in that location. You have to disclose this if you want to somehow get the airdrop, right? And the airdrop is driven on the layer 1. So anyway, you will receive this airdrop. That transaction will be on the blockchain necessarily. And so the proof will be disclosed if you successfully claim the airdrop. But your data lives in the layer 2 protocol and it's never disclosed. And even the proofs cannot be queried unless the user is signing the query. So even the proof, it's not that dApps can just keep querying proofs for somebody. This person must sign the query. So, sorry? And the location?
One more time.
No.
No. I mean,
once you have been in the location with your IOPay mobile wallet communicating the trusted location to the layer 2 protocol, once you have been there, you can leave, and maybe it depends on the actual dApp, right? Our dApp allows you to claim whenever you want. As long as you have been there in the time range, we are not checking when you claim, right? But your dApp may be different. Maybe you also want the user to claim within 24 hours from when you have been there. That's just your own logic.
So for example, right now, we're here, I check my location, then let's say that this application was already deployed. In a week or so, I go home, and then I already checked in this location. So that information is there. Then I can just go and say, oh, I was here last week. And if it's within the time range, then I'll just be able to claim the NFT in this example.
Yeah, there are some, I think actually if you stop thinking, there are a lot of use cases. For example, one simple one is for, you may have participated to Web3 events where they ask you, when you buy the ticket, they ask you to deposit some staking tokens that they will return you only if you show up, right? That could be automated by this API. No need to do any manual check or anything or sending email or whatever. The dApp you can build an event, right? dApp where people that register to the event, we know this problem. We know it very well. We have our happy hour, and we can have thousands of people just registering, and nobody shows up because they just check in to every event, and then they just go where they want to go or where they can go, but they spoil our organization, right? Then you can very easily just ask them to stake in your platform, and then your platform will allow them to claim back their stake only if they've been in that location. Otherwise, they lose the stake, and then people will stop registering to every event.
He's passively aggressively telling you to come to the happy hour. All right?
If you come to the happy hour, it's limited spots, right? It's 30 people. So we may ask you if you have registered to the developer portal. That's the only thing we may ask.
But yeah, and I was trying to. I wanted to say something. Might have forgotten. Yeah.
My fault.
Can't think of
sorry.
it right now. No, it's fine. Yes, I'll come down.
Privacy and security around where the data lives.
Privacy and security around where the data lives.
Good question.
I mean, Abai, it's like, please let me go. Go for it.
I'll do this one. So currently our layer 2 protocol is still in beta. We still don't have a DevNet. Next, we have 1.0 release of the layer 2 protocol that's a single node. So it's not a decentralized network yet. And in this configuration, it's still a centralized service. So the privacy is protected the same way it's protected today, meaning that there is a central service, which is basically you who are deploying the dApp, you are also running the layer 2 node that collects the data. Not in this case, because in this case we are running it. But still, we are collecting the data of the users, right, on our node. So privacy is, in this moment, in this case, it's protected from going to the blockchain. So you're not disclosing user location on the blockchain, not even to the API queries. But it's still disclosed to us who are running the node, or to anybody who is deploying this node and doing a similar service. But next step is having the DevNet for this layer 2 protocol, where it starts becoming a decentralized network. Once this becomes a decentralized network, then things become more complex, because you can have community people running nodes here. And so definitely you don't want to disclose the data to anybody who can run a node, right? So basically to everybody. In this case, more complex algorithms and privacy-preserving techniques kick in. And we have actually released kind of a white paper for this layer 2 protocol. It's in 3 volumes. We have released the first volume. The second one is about IoT devices, SDKs, how to send data to this layer 2 protocol. And the third volume, we talk more about decentralization and how to face the problems at decentralization. But I can anticipate you that it's just not possible. I mean, if you decentralize, when you decentralize this layer 2 network, then you will only be able to send devices, will only be able to send clear data that is clear by its nature, like temperature data, climate data, right? Or asset data, right? It's not a device sending asset data.
Health data.
But like health data, right? These are the big markets for real world and Web3 and IoT. Health data, even energy, power consumption data, right? That's all. Even industrial data, right? These are all strongly sensitive data, and you're not going to send them to a decentralized network. The same way you're not going to send it to the blockchain. In this case, there are different architectures for the layer 2, and some of them expect the device to encrypt the data and only allow, for example, a specific dApp to only allow the dApp to share the data with a specific dApp, where the layer 2 protocol works as a forwarder somehow, but is not knowing what the data is about. Or the device could be building the proof of something and sending the proof to the layer 2 protocol. And the layer 2 protocol will just serve as, again, a post office forwarding the proofs to the blockchain. Then you have ZK, right, where you can provide ZK proofs and use these algorithms. But of course, when you start decentralizing and preserving privacy, you are going to face limitations, for sure, in what you can do. For example, you can use homomorphic encryption on the device and allow the layer 2 protocol to do some computation on the encrypted data without revealing the actual data. There is this type of cryptography that allows to do some processing on encrypted data, but these are very limited use cases. So yeah, the layer 2 is going to be decentralized, but this decentralization will also bring some limitations for sure, and also a complex architecture.
But I mean, at the end of the day, the idea is that data is yours, and you should be rewarded for it instead of just giving it away for free. and it should be given away only when you want to be rewarded. Any more questions? Okay. It'd be cool to have a picture all together, but I know that nobody's going to come here and take a picture with us. I mean, why would you? We only known each other for 90 minutes. Yes. Yes, you would? Oh, that'll be cool. Well, if you guys feel like it and you want to come here, we can all take a picture together. That'll be super cool. Just for us. I mean, we put some time and effort into this, but that'll be cool. Thank you, guys. Oh, awesome.
Oh, everybody, great. Thank
Yes.
you.
Could we have a photographer in the audience to take care of this?
Let's mint this location the vintage way with a picture.
Extra rewards for everybody. Andrew, are you able to take? Are you already doing it, man? Right? You rock.
Okay. Yeah,
Thank you, guys.
To use like for stream to earn, because I have a platform I'm building that basically this would be for implement forward.
Yeah.
And also to
Andrew, can you also take one with my phone?
about OPL Oasis policy layer that they can use on any Solidity or NVM or protocol that you guys should look
Yeah,
at.
come to the office. Sorry, come to the office. Come to the happy hours.
Talk more as well.
Wait. It's not working out. How many of you knew about IoTeX? I bet almost nobody.
I saw it on
Text
before the
on the side events.
yeah.
I jumped on that when I saw the side event stuff.
Food. Open bar. Only high-end.
From 5 to 7. 5 p.m. to 7.
Minchia, c'hai l'aglio che è veramente... Madonna!
qualcosa allucinante.
That's a worship.
We're going to be using you guys.
Using in what way? Thanks, I'm so glad you guys made it.
Yeah, I know. I
Awesome. Thank you.
Thank you. Mamma mia, che sudata. Perché?
Vedi che è difficile usare...
Ti ho detto, io col tuo ho cambiato subito, però non lo potevo fare io.
Bob, are we rolling? Death is not final, only a misunderstanding of time. The eschaton has always been imminent and is always happening.